All right, we are live. Hello, everyone, and welcome to the Golem 1.5 release live stream. Today, I think we have something very special for you all. We're going to walk through some of the features of Golem 1.5 real quick, and then my colleague Daniel here, who's lead of Golem, is going to live code a coding agent with a coding agent on Golem 1.5. Do I have that right, Daniel?
Yes, something like that. Not a real coding agent, but basically a first step towards one.
It's good enough, right? And I think this coding agent is going to really tie together a lot of the features of Golem 1.5 and show you how it really provides you with a complete feature set for building custom agents. So to kick things off, I am going to share my screen. One second. Daniel, maybe you can tell me if you can see this and if it looks good enough.
I can see it, but it's very wide, like widescreen.
I wish I could change that, but I have a
Yeah.
widescreen. So I'm afraid we're stuck. So the first thing I would encourage everyone who is watching this live stream to do is to head over to discord.com and join our community. I highly doubt you're going to be able to remember the combination of letters and numbers in that URL. So don't worry, just head on over to golem.cloud and there's a little Discord icon in the upper right. You can click on that. You can join our Discord. You can say hi. And importantly, for those of you who are here for the Golem Forge Hackathon, you're going to be able to ask questions at the end. And also, if during the presentation or during the live coding demo, you have any questions about Golem, please ask them on the Discord. We will take questions and I will get around to answering all of those. All right, so let's kick things off. So Golem 1.5 is a durable agent runtime. It's durable, meaning all the code that executes in Golem is executed durably. State is persistent. Code is executed transactionally. It's open source. And our secret sauce is that it's built on WebAssembly, which gives us incredibly powerful and fast and also cheap sandboxing for agents. That's, I think, orders of magnitude better than anything you can find out there that's based on VM technology. Golem is not a framework. It is a runtime. And the difference is pretty simple. A framework runs alongside your application and you own the process. And a runtime actually sits underneath your application and we own the execution process. And because of that, because your application, all your logic, all your tools run directly on Golem, that gives us superpowers. We can actually give you transparent, invisible, durable execution over not only your agent logic, but also over all the tools that you write and execute on Golem, which means you get stuff like exactly once communication semantics between agents in agent swarm problems and also sub-agents and whatnot. You get exactly once tool execution, even in the presence of faults or human in the loop or other types of things. All of the stuff that's really, really difficult or impossible to do with frameworks you get for free out of Golem without having to do any sort of code annotations, without having to use any magic strings in your code, without having to instrument or anything. You just write ordinary code. And because Golem is the runtime layer that executes it, we can give you all this powerful features for free, as well as ultra cheap per agent sandboxing and some of the other stuff that I mentioned at the start of this. This is the history of Golem 1.3. We sort of pivoted our terminology from workers to agents and started really specializing on the AI and agent marketplace. And then in 1.4, we introduced a new feature, quite significant, code first agents that dramatically simplified the way that you built agents for Golem. And then in 1.5, the theme is sort of agent first everywhere. Everything is just agent first, the command line interface, the configuration, manifest files, secrets, all that stuff. It's agent first everywhere. We have 17 new capabilities in 6 different categories. Real quickly, new languages. We have support for Scala. So all the Scala developers out there are encouraged to check this out. We have great support, I think, for Scala 3 and an SBT plugin. You can use ZOHTTP client if you want to, and a very clean declarative API that is very similar in nature to our Rust API. So it's basically one-to-one with the Rust API and lets you code using asynchronous futures. So super declarative, very easy to use. That is brand new. We also have, courtesy of Daniel's pet project, Moonbit support. So Moonbit is basically, it's a lot like Rust, except it has a garbage collector, so it's way simpler to use. It's a lot more fun and joyous to program. And we have great support for that, I think, thanks to some of the work that Daniel's done. Moonbit is like one of our favorite languages to work with, especially in the WASM ecosystem, because it generates such tiny binaries and they start up really, really fast. There's no junk, there's no cruft here. And the stuff that it generates is super clean and a great fit for WebAssembly. So if you're looking to do the hackathon, for example, in a programming language and you like what you see here, then definitely give Moonbit a try. We have supported TypeScript for a while, but I will say in this release, the Node.js support that we offer has been tremendously deepened. Most JavaScript libraries and TypeScript libraries, they just work out of the box. And there's been a ton of validation work on like popular open source libraries to make sure that they work, their tests work, etc. It's all in really great shape for building applications on. TypeScript and Rust, they're in there and they're still in there. We continue to support them. I think Rust is a fantastic language for building agents because you get the performance benefits that comes with using a language like Rust, but you also get a lot of these security guarantees and safety guarantees you would not get out of a C or C++. So increased speed without sacrificing the safety, the memory safety that is so important when you're building any sort of modern application. Number 2, we've gone to code first everything. And that means code first routes. You no longer have to define your routes in a YAML file and use the rib programming language just directly inside your code. You just annotate where you want external endpoints, and you get the routes in our API gateway, Golem's API gateway, for free out of that. You can even generate open API docs from that in a declarative fashion. Phantom agents are now a first-class feature here as part of the API. All you have to do is denote an API as an endpoint as being Phantom, and what that gives you is the ability to every single request that hits that endpoint is going to be done on a new sort of Phantom agent. And that allows you to have basically a durable version of AWS Lambda that can handle long-running computations, which can be useful for some applications. Our configuration is now 100% type and code first. So you go in, you define the configuration required by your agent as data types. You mark that in a way that's shown here for the TypeScript example. And then Golem will figure out what that is and make sure you have appropriate config of the right types and right structure when you go to deploy so that that agent can get its configuration. And this also includes support for secrets. So you can store API keys, for example, and whatnot. Very common when you're building one of these custom agents to need some API keys or other credentials. And now you have support for that directly in Golem. We have support for webhooks, which is fantastic for building human-in-the-loop flows where your agent needs to pause based on some external interaction. And it's also useful for long-running workflows with human supervision, and all sorts of other stuff. Very simple API here. And then the manifest file has trimmed. It grew quite large, and actually when you created a new Golem template, there was just a lot of stuff generated, and now it's really tightened down. Our interop surface has undergone a bunch of improvements. For example, you now have push button MCP servers. So if you write a bunch of code on Golem, and then when you want to use that as like a durable tool framework, or you build agents and you want other agents to be able to use them as MCP tools, you can now push a button in your manifest file and you can export all of your code as MCP tools. You don't have to do anything other than the configuration that you see there. We now have bridge libraries, which are basically libraries that you generate to run outside Golem that can call into Golem as if they were running inside Golem. This is useful for interop. You have some big application, you want to programmatically delegate work to agents or workflows or tools that are running inside Golem. You want a type safe API for that that's written in the programming language of your choice, for example, TypeScript, and the bridge generator can generate that code. And this also allows you to, for example, maybe your part of your application is TypeScript, and you want to call into some Rust agents that are running inside Golem. You can do that cross-language bridge generation as well. Our REPL is better than ever. TypeScript REPL here. You can see that is the standard. We're heavily investing in making that TypeScript REPL even better. You can use the TypeScript REPL for Rust as well as Moonbit and Scala. At some point, I think we will have a Scala REPL. We tried the Rust REPL, but it didn't work out so well. And I don't know about Moonbit REPL. I don't even think we thought about that. But the TypeScript REPL works great, and it works great for all the languages out there. We now have direct support for WebSockets, which is really simple in TypeScript, JavaScript. It's just implementing the existing WebSocket API, and looks a little different in the other languages. Our runtime semantics have, I think, improved quite significantly. We had some built-in automatic retry stuff that was not customizable and worked at a very low level. And so we've overhauled that. Now our new retry policies are driven by predicates. They're compositionable. You can update them live. You can customize them as much as you want. And I think they operate at a higher level. So for example, this particular retry policy works on HTTP requests. So you could say, oh, I want to retry 502s and 503s and 504s. And I want to do that by using some sort of exponential policy with some jitter, max retries, etc. Snapshots is a new feature, and this allows you to do really fast recovery. If you want to customize things, ordinarily Golem sort of keeps a complete durable log of everything that your agent does, and it uses that to recover state. But if you want instantaneous recovery, then you can just override some functions here and capture state yourself and restore state yourself. And that enables your agents to sort up immediately, which is useful if it's useful, especially I think when an agent reaches a boundary, it's not doing active work. It's not in the middle of a tool call or something like that. It's not doing active work, and you want to be able to snapshot it. So the next time it's used to do something, it comes back just like that. Everything is made per agent, and where you see this a lot is when you're working in the manifest file. The manifest file is now agent oriented. So you can say this agent has these environment variables and this file and this config, but then you could say this other agent has its own stuff. Quotas are a new feature, and I think one of the first features we made that's sort of really specializing in on our market here, our target market for Golem. You can define custom quotas, and they can be rate-based or capacity or concurrency-based, and you can have policies about what to do when an agent exceeds a quota. Like, for example, you might want to throttle, basically suspend agents that are exceeding their quotas, or you might want to terminate an agent if it exceeds a quota, or you might want to reject the agent from being able to reserve some number of tokens or API calls or whatever they are. Obviously, for building AI agents, the number one use of quotas would be in tokens, but you can also use this for API calls or any other features that you want like that. And this knowledge of sort of, how much you're using of these different resources is baked into the runtime, and the runtime can do true preemption of your running code when these quotas are exceeded, and it can decide to suspend or terminate as you decide. All of this retry, snapshots, config, quotas, they all work flawlessly with replay. So again, if there's a fault, if something happens in the middle of a computation, everything just works the way you would expect. And then finally, we have some stuff around production readiness, open telemetry plugin that does some traces and logs and metrics, allowing you to see what's going on inside your Golem cluster. Very easy to configure that. We've pared back templates to the bare bones, and we simplified the process by which you might upgrade from one version to of Golem to another version with the manifest files and any changes that there might be in our build process, build and packaging. We now have lots of agent skills. Every time you create a Golem application, you get a bunch of skills for your coding agent to teach your coding agent how to do stuff that might be Golem specific or might be influenced by certain limitations or design decisions in Golem. And that's benchmarked against a variety of different coding agents out there to make sure those skills are actually being used and they actually result in the success of the agent that attempts to use them to solve a specific type of problem. All right, and then finally, real quickly, that's what has shipped in the 1.5 release, which we're announcing today, and then a brief sort of sneak preview of where things are headed in 1.6. We want to do a few, I think, really cool, innovative ideas, all of which are based on this notion that Golem is a runtime. It's not a framework, and so it can really give you superpowers. You can do things in a runtime that you can't ever hope to do in just an SDK or a framework that runs alongside your application. And some of these are around agent tools. I think that's the big feature in 1.6 is agent tools with us, but also agent permissions, which is a new permission model that lets you sort of lock everything down and operate in a sort of trust nothing environment where nothing can happen unless you have said it can happen. A human might be involved, or you might decide to not involve a human. It's totally up to you. Support for A2A protocol. So agents you build in Golem can talk to other agents outside Golem and vice versa without you having to write any code. And then some improvements to all the SDKs, really, but especially to the TypeScript SDK. And then some other stuff, which is going to be very important, I think, in later versions of Golem, will be durable streams and async streams, which is going to be incredible. It's current. I think one of our weaknesses is we don't have really good story for durable streams. We support WebSockets and other stuff like that, which doesn't have very well-defined semantics in the presence of faults and restarts and suspensions with human in the loop and other sorts of things. And we're going to have a really good story there, an absolutely bulletproof story there, I think, with the durable async stream support that's coming. We're going to verify every single agent can have its own SQLite or Terso database for purposes of sort of learning as it goes. You can already do this. We're just going to make sure it's all fully baked. And then we're going to do some scalability and performance tweaking to make sure that you can run thousands of agents per node in a cluster without running into any sort of scalability bottlenecks. All right. So we are going to now watch as Daniel demonstrates a lot of the features that I just went through and explaining in building a custom coding agent that runs on Golem. And after that, we will talk about the hackathon, the Golem Forge Hackathon. I'll give you the rules and how you enter, how you submit your solution as soon as we're done with this live coding demo. All right, I will stop sharing my screen and turn it over to you, Dan.
Yes, thank you. And trying to share my screen. Did it work?
Yes.
Yeah, I think so. Okay, so you already explained all the features that I was planning to explain, so I will just
made your job easier, I hope.
Code, yes. So, yeah, what we are trying to build today is, well, I didn't want it to call it a coding agent, but it's going to be some kind of a code analyzing agent. There will be repositories, GitHub repositories that are checked out into the sandbox environment of each agent. Each agent will be responsible for one such sandbox checked out Git repository. And we will be able to ask questions about the code that is answered by calling to OpenAI. The questions and answers are going to be cached and exposed in various ways through Golem's new capabilities. So let's start by actually starting the server. I'm going to develop with a locally started Golem server. And I just wanted to prove you that it's starting from clean, so nothing is prepared. And then the version I'm using is the Golem 1.5.1, which is the official Golem 1.5 release that is available right now. You can download it and run it. And let's start by creating a new project in the directory called, let's say, agent. And as you can see, as John already mentioned, we have 4 languages to choose from now. We use TypeScript. And another new thing is that you can select multiple templates to be included in your application that you are generating. But we are going to throw away the whole thing anyway, so I'm just choosing the simplest one. And now we can see that it created a new directory called agent. And before doing anything else, let me quickly show it in an IDE. Trusting it. Yeah, so what I wanted to show is some of you may use the Golem before and remember that when you created a new project with Golem New, it was quite complicated with many directories, with a lot of files that are Golem specific and not easy to understand. What we have now, in the root directory, of course, there is a git ignore file, and there is an agent md, which is just an initial agents file for helping developing with coding agents. But other than that, we have a Golem app manifest that John was talking about, which is really simple. It says the application is called agent, which is not a very good name, but that's it. This is just your application's name. It lists a couple of environments where we can deploy our application to. And we are using the local one in this demo. And that's it. Other than that, here we could list agent-specific environment variables and configuration and so on, but we don't have any in this initial state. And we can also decide what to expose through HTTP, but I will get there later. And other than this manifest file, everything we have here is just what you would expect from a TypeScript project. We have a package JSON, which depends on our Golem specific SDK and on some rollup stuff for bundling. We have a TypeScript config file, which is just a regular TypeScript config. And then in the source directory, we have this main TS, which is basically empty, and our example of a counter agent, which I'm sure many of you have seen a few times already. But it's just a stateful agent with a name and a counter. And we are not going to look at it for any longer. Don't worry. One more thing that we have in this newly created directory is an agent skills directory, which is managed by Golem CLI. So if you update to a new CLI version, these Golem specific skills, which as you can see, there are many, are going to be automatically updated to match the latest version that you have upgraded to. Okay, so let's go back to our terminal and start a coding agent to write the coding agent. And yeah, the first thing that I'm going to do is remove the counter agent and add the new agent called repository that gets GitHub owner repo and a branch name as parameters. And no agent methods yet. Let's see what happens. What will happen is that it's figuring out that this is a Golem application, finds all these skills, spends a lot of money, and eventually it's going to delete our counter agent and start with a new thing. Let's details, toggle details. Yeah, so it created a new repository TypeScript file, removed the counter agent TypeScript file, and it's also going to build and deploy it, I guess. But until it's done, let's just take a look at what it did. So yeah, looks like it did exactly what I asked it for. We have an empty agent with a constructor that points to a GitHub repo and a specific branch, and it has no other functionalities yet. And it also removed the counter agent from the HTTP deployments because we no longer have a counter agent. So what we can do now, for example, well, we could ask the agent to try it out, but let's first do it ourselves by golem build. The first time it detects that the npm packages are not installed yet, so it's installing them automatically and the build is done. And then we can call, for example, golem deploy, which is going to deploy this thing to our local environment. It shows nice diffs about everything that's going to be changed, and we accept that, and we are done. And still nothing to see here because it's an agent that does nothing. But let's go back to our coding agent. And the first thing I want to add to this repository is the ability, I will add an update method, and a method called update that is going to basically do what git pull does. It's going to pull the latest version of the branch that the repository agent is pointing to and store it in the agent's local file system, which is a fully sandboxed thing belonging to that particular agent instance. And we can use the isomorphic git npm package to do the git part. So let me write this down here. So we are also going to expose this git hash of the last pull thing as another agent method, so we can actually see something while we are getting to the more exciting parts. And yes, it's now installing the new dependency, which we can now use because, as John mentioned, our Node.js compatibility was improved significantly, so we can just pull in these third-party dependencies, and it added 53 packages. I guess some of them are one-liners, but still they are all working. And what's going to happen? It's thinking too much. Yeah, so the idea is that this update method is fetching the files, and then we are going to add more agent methods that are actually working on this locally checked out repository. I'd already implemented it. Now it's calling golem build, and it has an update and the get hash method. And I can ask it to try it out with my testing library. Let's see what happens. So it's going to understand that it has to deploy this thing and how to invoke it to see that it works. Yeah, so I tried to invoke it without deploying it, but now it's going to figure out that it has to be deployed first. And it's already happening. And it's invoking it. And it failed with something. Now it worked. Yeah. So it shows invocation result is a git hash, which is my latest commit hash in my testing libraries repository. So now let's take a look at this new REPL that was mentioned. So if I say Golem REPL, then previously in the previous Golem versions, we got this custom scripting language called rib, which was a weird syntax that you had to learn. But this one is just a real TypeScript repo. We can do console log hello world, and it's going to work. And it also printed that we have a repository.get constructor to get an instance, a client to our repository agent that is running in Golem. And we can call these methods on it. Let's see how that works. But before that, one more thing that our REPL is supporting is everything that you can do in the Golem CLI, you can also do it from the REPL. So for example, we can do agent list, and it's the same thing as typing Golem agent list in the CLI. And it shows us that by the coding agents test, we already have an instance of this repository agent with these constructor parameters. And then we can just create variables here like TypeScript, REPL. We have to use the get thing because that is the syntax that we are using and we were already using in previous versions to get to refer to remote agents when we are doing agent-to-agent communication from code. And we are mirroring the same thing here. So you are using the same syntax in the REPL that you would use in the actual code. And now we have tab completion for this. So we can say get hash. And it returns the same thing that was previously returned by our agent. So let's see what the code looks like because we haven't checked it yet. And yeah, it's now importing the Git things from isomorphic Git and the Node.fs for working with file systems. And in the update method, it's just creating some temp directory in the local file system, which is, as I said, it's not our machine's root file system. It's something that is a sandbox associated with that particular agent instance. So for each instance, we are getting a completely empty virtual file system here. And then it just clones the repo and stores the hash. So far, it's very simple. We should actually improve this update method by asking it to not do any pull if or not do anything basically if we are already in the same hash that is the head commit on the remote repository. Because we are going to do some other stuff in the when we are updating later. So we are going to store questions and answers that we made on this repo. And if we are updating the code base and it's actually bumping from one commit to another, we are going to throw away the cached questions and answers. So it's doing something, deploying it again. Finish deploying it. And it's trying it out. Yeah, don't look at that agent result is not a single return value error. I don't know why we are getting that, but everything is otherwise working. So it's changed the code by this checking the remote head commit first and then returning if it's the same as that we already have. All right, so the next step is to actually start using an AI agent, OpenAI as a provider to be able to ask questions about this repository. And previously, we were shipping Golem-specific AI libraries that we are no longer doing only for Rust. The reason is that our Node.js compatibility is now good enough that we can actually just use third-party libraries, which is a better choice. So we can use all these things like Versal AI, Effect AI, TenStack AI, all these libraries are available for Golem to be used. And in this demo, I'm going to use Versal AI and going to connect to OpenAI because that's what I have a token prepared for. So let's tell it to use Versal AI to connect to OpenAI and expose an ask method that takes a question and asks the AI to answer it based on the checked out repository, and define some tools to look at the files like read file and list files and so on. And let's see, that's I think should be enough to get started. And one interesting thing that I'm going to be able to demonstrate with this is the new configuration and secret handling, because obviously to connect to OpenAI, we are going to need an API token. But as you will see, it's not going to use it by default, and I will show why instead. Now it's figuring out how to use Versal AI. Already installed it. And very soon, we are going to be able to look at the code. Yeah, so as you can see, in this diff, it added the OpenAI API key as an environment variable. And if we go to the manifest, we can see it's here. The reason we have already had it in previous versions, this nice way to set an environment variable for the agent by taking the value from the host machine's environment variable. This is very easy to transfer these values from the host machine to the agent for testing. It's going to be set deployment time. So why did it use environment variables and not our configuration system? And the reason is that in Versal AI, if we check the code that it has written, so it has written an ask function that takes a question and returns a string, which we are going to be the answer. And if we haven't run update yet, it's going to fail. That's fine. And it calls generate text, which is a function from Versal AI itself, and sets it up. I'm going to use GPT-5.4 instead. And it has a system prompt, and it passes the question. And it already defined these tools that I asked for. So it has a list files tool that is just using the Node.fs module to discover the file system. And it also has a read file tool that is also using the Node.fs module to read a file. Of course, in a real world scenario, there would be more sophisticated tools that are allowing things like reading the range of a file and so on, but it's not needed for this demo. So the reason why it was using environment variables is that Versal AI is by default using the environment variable, which I'm sure is documented somewhere, which we cannot see now. But as you can see, it's not doing with the environment anywhere. So there is no mentioning of the environment here. Versal AI is just using it, taking it from the environment if you are not specifying it by hand. So the agent took the simplest path to get this working. But we are going to change that. So let's go back to the agent output. And it already did a test as well. So it asked, what does this repository contain for my test library? And here we can see that it got an answer. So the repository contains a Rust project with several notable components and so on. So it's working. All right, so first I forgot to instruct the agent to add some log statements to our code, just because that will make some demonstrations more easy to understand later. And the other thing we want is that switch to Golem's configuration and secret management for the API token. It should be a secret. Yeah, so it's adding some console log statements now. And it's going to, yeah, it's first it checks whether the logging is working. That is a bit unnecessary, but anyway. Now it's going to remove the environment variable and replace it with a agent secret, which is a new feature of Golem 1.5. And yeah, until we get there, I should explain what the difference is between configuration secret and environment variable in this context. So unlike environment variables, configuration is typed. If we take a look at the file here, now we have a repository config file, which only contains a single key, but it could single field, but it could contain as many fields as you want. It can be also nested, and it's well typed. And Golem guarantees that you can only deploy something if you satisfy its configuration and it satisfies it with the right typed values. So it's much more advanced than just passing things as strings to environment variables. And secrets are all the fields of a configuration that are wrapped with this secret type from the SDK. And the difference between configuration and secret is that configuration is, as I said, satisfied during deployment, and it's static. For a given deployment, it's always the same values. And secrets, on the other hand, are associated with the environment where you were deploying to. If we go to the manifest, we can see that we cannot see that yet. All right. So yeah, we can ask it. Interesting. In the afternoon when I did the same thing, it was automatically doing this, but add the default secret value to the manifest. So we can define secret value. So I hope it's not going to read my environment variable. And okay, yeah, it worked and print it. So we can use the same syntax that we were for environment. We don't need this, but it was actually valid syntax, just IntelliJ doesn't think so. So we can do the same thing as we had with the environment variables to set it from my environment variable, but now it is a secret. And because it is a secret, we can see that, for example, secret list will show that we have an OpenAI API key secret, which it's not showing its value. We could, if we want to, which shows sensitive or something like that. And we can also update the value of this. And I'm not going to do that now, but we could just basically write OpenAI API key, new value, and this is something that gets applied runtime, so you don't have to redeploy anything. And the way it works, if we go back to the TypeScript file, is here, not in the ask function, where we were previously just calling the generate text from Versal AI. Now we are creating a provider by hand in a in a prep step. And here we are reading out the API key from this secret. So the secret wrapper around the string here, but it could be other types as well, has a get function. And this get function lazily loads the most actual value of this secret. So even if this agent is running and we are updating and rotating the API key, it's going to use the latest one for the next request, which is very nice. So yeah, it's actually, even before we did this, it already tried it out again by asking, where is it? What is the project name and what does it do? And it answered the project is testar and it is a test framework. So it's still working. Okay, so what next? I said that we are going to cache these answers. So let's add that next. And because Golem is durable, we don't really need to do anything special here. We can just store it in memory. And we are going to expose some new agent methods to query this. So basically what I expect that it is just going to add a map field to our repository class and 2 new methods to query this. And while it's doing it, let me tell what this will allow us to do. Well, it's not really a requirement for what I'm going to do next, but it makes it nicer. What I'm planning to do next is add a new tool to our AI that allows it to ask questions about other repositories by doing agent-to-agent communication between our repository agents. And before we do that, just let's take a quick look of what it did. It introduced the cache, which is just a string-to-string cache. Now ask is returning the cached value if it's available. And it's setting the cache when it was calculating a new answer. And it just has these 2 helper methods to return the list of keys or to return something which is a typed question answer pair. And let's see, it was building it and it was not trying it out. It got lazy. Earlier this afternoon, it was trying out everything automatic. So let's see. So yeah, it's redeploying it. And when it's using the redeploy agents, it means that it clears the state of our agents, so they are going from scratch, but it's recreating the same ones that we already had. It's just a convenience for iterative development. So now it's asking a question, what is the project name? It takes some time to answer this very hard question. Yeah, it has the answer. And now, as you can see, we added logging. So now it also, the invoke command streams the logs like console log, console debug, all these things. And you can see it here in the output. So the project name is testar, and it's now asking some other thing. What is the project name? From the logs that has streamed, we can see that it's a cache hit, so our cache is working. And it's asking something else now. What language is this project written in? Hopefully it's going to say it's in Rust. Otherwise, I'm going to be surprised. And once we have finished verifying these things so far, we are going to add the cross-repository RPC and expose it as a tool. Actually, I can instruct it while we are waiting. Add a new tool that allows the AI to ask questions about other repositories, agent to agent communication. So things are quite slow now. Maybe it's a slow response from OpenAI. We can also see what kind of agents have we here. Still the same one. And we can also do things in the wrapper, like see the uplog of this thing. And we can see that all the information that is persisted about this agent is available. And of course, this can be filtered somehow, like, I don't know how. Query with query. So we can say we only want to see the logs, and then we only see the logs, and so on. So let's go back here. I don't know why is it. All right. Anyway, it seems to be, maybe it's just the AMP code that is failing to see the invocations output. It does it from time to time. So let's just override this and go to the next topic. Also, this is AMP code beta, so it's failing a lot. Yeah, like now, I think. All right, so let's restart AMP code. AMP code should be running on Golem. Maybe this helps. So it got back to the same thing. And still connecting. Otherwise, if we see agent get, oh, not for that. Yeah, so we can see that our agent, repository agent is actually idle. So it's not doing anything. There is nothing to wait for. So let me switch back to the old AMP code version, I think. Which is not the beta version. Of course, we cannot do it because it's a new. Yeah, so let's start a new one. Sorry about that. So this is the old AMP code version, and now it has no context about the whole thing. So I hope it will still work. Let's say what I wanted to do is add a new tool to the OpenAI call that allows the AI to ask questions about another repository using agent-to-agent communication. And try it out by comparing this with another library from it. So yeah, we have to wait until it figures out where it was, what this whole thing is about, but I think it's going to be fast. And until it's done with that, let me explain what are the next steps that I'm going to do after this is proved to be working. So yeah, so now that we have this repository agent that is capable of asking questions about repositories and storing them and so on, we've seen that we can use a CLI to list what kind of repositories we have available, what instances we have of this repository agent. But this agent listing interface that the CLI provides, and of course there is a REST API that can do the same, but it's not really made for using within Golem applications. It's slow and it's inconvenient to use. You shouldn't rely on that to, let's say, if you are trying to write a front end for this application and you need to list all the repositories that are available. You don't want to do this with the same, with this agent listing interface. Instead, what we can do is we can introduce a new singleton agent called, say it's going to be called repos. And that singleton agent is going to be responsible for knowing about all the repositories that were created before. And this way we have a single source of truth to get to ask what repositories are there, and whenever we are accessing a repository, we are going to go through this singleton agent, and that's going to be like a get or create wrapper around our repos. And this step is going to allow us to expose the whole thing through HTTP, through MCP, and so on. So now what the agent is doing, it's already trying out stuff. Yeah, it cloned the test.r repo, and now it's asking a question. I never heard of this test case library, so I'm curious what the results will be. Let's see. Compare this library with the Rust test library. And if everything is working, what I'm expecting that in the end, we are going to have two repository agents if we do an agent listing, one for the tester and the other for this front house test case. And we can verify that in the repo and see. It's cheating a little bit because it's instructing it to use the ask other repository tool, but whatever. It is supposed to work without that as well because the tools are discovered by their description anyway. So let's see what's going on here. Yeah, we have these two agents now, and they are actually running. So that means that this one is still waiting for the other one to return an answer. And it's for some reason taking some time. We can try agent stream to get the logs out of this. And now you can see that it was reading all kind of files, figuring out an answer, and it answered something, but we haven't returned yet. What happened? I don't know what happened, sorry. Now both of them are idle. So we have the answer here, which is a comparison of the two repositories. It's hard to read because the agent is not properly formatting it, but we could ask it to. Yeah, actually, it already did it. He finding that task is a lightweight compile time testing macro layer, and test.r is a full alternative test framework. So this is working. Let's see how it implemented it. We should see a new tool in here. It's here. Ask other repository. It's a tool. Ask question about a different GitHub repository. This is very important because in Golem, invocations are sequential. So if you are and cannot overlap. So if you are in the middle of an invocation and you will ask yourself through agent to agent RPC about another question, that is not going to work. It's going to actually fail, detect that this is a cycle and it's going to fail, I think. But anyway, the agent properly understood that this is not possible and instructed the other agent to not do that. And the execute part of the tool is what actually target repo, target branch question is the input. And here is the main thing. It uses the same syntax that I was using in the, that I was using in the REPL. So repository has a get function that takes the same arguments that are in the constructor of repository, but it returns a client of repository. And this client wrapper just has async functions for every agent method that we are exposing. This is not new in Golem 1.5. It was already like this in the previous release. You can see we can call ask, we can call the get hash, the get cache answers, all these things. Oh, and one more thing, the reason why this is so this is a remote method and not just what you would expect, is that it has some additional features. So if you do it like this, here, if it would have parameters, you could pass them, and you can await it for to get the result from this remote procedure call. That's the simple default thing. But you can also do dot trigger, which means that this is no longer an async function. And you cannot await. It's just enqueues this invocation in the remote repository's invocation queue and immediately returns. This is very useful for some patterns. And you can also do schedule or schedule cancelable to schedule an invocation in another agent at a given point in time. But we don't need this right now. Yeah, so as you can see, it gets a handle on the other repository, calls update to be sure that it has the contents, and as we implemented it, it's a no if it's already on the latest version. And then it asks the question, awaits the answer, and that's it. That's how we integrated our Golem-specific remote procedure call to our OpenAI chat session. So, yeah, let's play with the REPL a little bit more. I just had to restart it because some weird behavior. So let's see, let's get back the handle to our test our agent, which is already existing, as you can see. So we can see, we can get the get cached questions. And you can see that is what the agent was testing with. This is just a question. And we have the get cached answers as well. And now here is the detailed comparison of the two things, two testing libraries. But we are still only experimenting with the REPL and through the CLI using the agent. So let's get to the next step that I already explained. And as a first, before we are exposing this via HTTP, we are going to add this singleton agent that keeps a track of all the repository instances. It should have a get all and as a whatever create. I don't know exactly. Get or create. Yeah, let's see what it does. So I wanted to explain what a singleton agent actually means, and we are going to look at the code in a minute. But as if we go back to the repository agent, you can see that its constructor consists of there's three things, but one of them is special. The config is a special thing. The other remaining constructor parameters are what are defining the identity of our repository agent. So every repository that has a different owner repo or branch are going to be a separate instance in Golem. And this means that a singleton agent is nothing more than just an agent with no constructor parameters, because you just simply cannot express multiple instances of that agent without anything in the constructor. And yeah, it already created this new thing. And yeah, it didn't create a constructor for it, so it's going to be a singleton. And it has a list of the repos, which is just the pair of owner repo and branch. And it has two agent methods. One is returning all of them. The other is checking if it exists. And if not, then it gets it through RPC, and we should also instruct it to call update on it. Because that just makes it more convenient, but it doesn't really matter. So how are we going to use this? We are going to create a third agent that is going to be our facade for exposing all these to end users via HTTP and other communication channels. And why is it necessary? As I said, this is a singleton agent, and I also said that every agent is sequentially executing the invocations that they are getting to the invocation queue. And that is not a good fit for, let's say, an HTTP API. You want multiple incoming HTTP requests to be served in parallel, and that is not going to happen in a singleton Golem agent. So we are going to put another one on top of this, and that is going to be an ephemeral agent. Ephemeral agents are looking like Golem agents, but every single invocation creates a new fresh instance. So it always starts from fresh state, and after the invocation, it gets thrown away. You can still look at its logs and so on, but it's never going to be reused for a future invocation. And we can really nicely map these ephemeral agents to be HTTP request handlers using the new code first HTTP feature. All right, so it tried it out, it works. We can also try it out in the REPL, although maybe we need to reload. No, that's not enough because we defined a new agent. So in this case, we are restarting the REPL to have access to it. But now we can see it here, repos is available, and we can say await repos.get all. And we can see that it has the single repository that the agent was trying out. So let's do the next step. Let's define a repository query ephemeral agent that uses repos and repository to expose all the functionalities through HTTP endpoints. This should, yeah, it's going to do the same thing that I just explained, hopefully. So let's wait a little bit. It's reading some skills. And it started creating a new agent TypeScript file, not written yet, but very soon, yeah. So now it's here. We can already take a look. So what it did, it defined that this is an ephemeral agent. And that is very important because that is what guarantees that every incoming request we are going to create a fresh instance, and incoming requests are not going to wait each other. That also has its place, and sometimes that is what you want, but not for this particular use case. And the other property here is mount, which is defining the root HTTP path for these endpoints that we are exposing here. And then every agent method is annotated with endpoint, which is defining the agent, the HTTP method, get and put and post and get and so on, and also the path. And as you would expect, when something, an agent method has parameters, these parameters can be mapped to path segments, and query parameters and headers and all these things are supported. And that's it. And yeah, and if you are defining, yeah, so this is a good example of that. So for ask, it mapped the owner, repo, and branch to the path, but question is not mapped to the class, to anything in the path, obviously. So everything that is not mapped in the endpoint decorator is expected to be a field in the JSON body that is passed to this post request. Yeah, so it seems like it expressed everything. And what I don't like it's not really enforcing that everything is registered to the repos agent. So I'm going to ask that. What was it called? It was called, yeah, so this is not the best design I'm aware of, but we have limited time. And yeah, it says it created all these endpoints, and it also verified some of them, or most of them. So if we scroll back, we can see that it's doing curl request to agent.localhost with these paths that are mapped to our repository agent. And it was getting the responses that it expected. So it's working. And now it's making these changes that I asked for. And one more thing that I wanted to show in this step is, yeah, it's doing the right things, but it's not very interesting to watch, sorry. What I wanted to see is that we can do something like that. We can, so automatically you are getting an open API specs for all your endpoints that you define. And we are just have to refer to the root openapi.yaml path, but that can be also configured somehow. So let's try that. And here it is. So this is an open API spec that contains everything that our code first repository query agent was exposing through HTTP. Oh, and yeah, and I should show that in the manifest where you previously had to list all these things, now we are not listing any of these things, only this very short list of the agents that we want to deploy to a specific domain. So now we want to deploy for this local domain and only this agent, but that's all that you have to specify here. And okay, it's done with my cleanup changes. And what I want to see next is expose repository query for MCP as well, because that's also a new feature in Golem 1.5. And it's very easy. Actually, this is all that you have to do, what the agent just did. Add an MCP section in the Golem manifest, and in the same syntax as you did with HTTP, just list all the agents you want to see through MCP. And it's already deployed it, and it's trying it out with curl. And I cannot read MCP protocol out of my head, but I trust the agent that it properly tried it out. So it was listing the tools, I guess, and it's using the JSON RPC protocol that the MCP specs are describing. And as you can see, it's answering as you would expect. And it was trying it out. And there is a default mapping that you can read in the Golem manual, that everything that has a parameter is mapped to tools, I think, and everything that is not having any parameter is mapped as a resource. All these things are documented and documented in the Golem website. So there are only two more things that I want to show. And one of them is, John mentioned that one of the new features is the quota support. So here in this agent now, we are just calling OpenAI without any limit. And that's many times not what you want. So as he said, you can use this quota support to rate limit APIs, but it's also a very good fit for actually rate limiting or limiting in various ways AI requests, because you can map the token use of the AI APIs directly to our quotas feature. So probably many of you know, but when you are calling, for example, OpenAI in this question, in this example, when it returns, it also returns the number of tokens it used. So we can do the following. We can define OpenAI as a quota resource in Golem with some available pool of tokens. And we can borrow some tokens from this pool before we are doing the LLM request, and then we can return with the number of used tokens, and that is going to be recorded as tokens that has been burned. And all this thing is tracked in Golem, and various behaviors can be configured. For example, it's possible that you don't want to use more than 100,000 tokens per hour or things like that. And when there are no more tokens to get borrowed, it's not going to crash. It's not going to get into an infinite retry loop or anything like that. Your agent is just going to suspend, not consume any resources, not cost any money, and wait until it has some available tokens to use. So let's ask the agent to do this. Maybe this is enough for it. Let's see. It's already reading the Golem quota skill that explains how to do these things. So that's a good sign. And well, this is something that we cannot really demonstrate. I mean, it's too hard to demonstrate it, but I'm going to explain the code that it created. As soon as it's ready, and hopefully it's also going to demonstrate that the things are still working. It's importing some quota-specific things. And now the main thing, yeah, it's going the right things. Just a second. but I can already start explaining. So first of all, it added a new section in the manifest called resource defaults. It's in the root of the manifest, like the secret defaults, because it's also something that is per environment. So local here is your local environment. That is my local server. You can configure these things different for different environments. So for example, if you have a local testing environment, pre-prod environment, and your production environment, you can define different secrets, different resources, different everything for those. And it defined a resource called AI tokens, which is a rate limiting quota with these parameters. And the enforcement action is reject. That is not what I was describing. Reject is that it's just not basically throwing a failure or something. I mean, no, throwing or returning with a failure that can be observed by your code. So you know that it's rejected and you can decide what to do. But just asking to use throttle instead, which is what I was describing, that your agent is going to sleep until it can get more or enough tokens that are available. So it's doing this, just change the configuration. It's now trying it out. And just to take a look what it did. So in the constructor, created this AI quota field, which is just getting a handle on this whole thing and registering the intent that this agent is going to need tokens out of this pool of tokens. And then in the ask function, we've wrapped the word generate text with reservation. And this is what is doing the whole thing of asking for tokens and suspending if needed and so on. And when we are returning, now we are storing we already have the response from generate text in this variable called R. But now we are not only using the text from the response, but we are also getting the usage total tokens field from it. And this is what we are returning here. Not only the response, but also the number of used tokens. And that's how with reservation can know exactly how much your AI library was using, even if that's a virtual AI call and it knows nothing about Golem. And it tried it out. Let's see what it did. It was asking, just respond with the single word hello. Very nice use of this technology. All right, but it worked. And it tried it out properly. So it was logging the number of tokens. It was allowing it because it's just 300 tokens and not 200,000 that we allowed or something like that. And Golem resource list, which we can also do here, shows that we have this AI tokens resource defined. So this is, as I said, it's not very interesting to see this because I would have to set up some scenario where I'm actually overusing my tokens and get rate limited and so on, but I'm not going to do that now. And the last thing I want to demonstrate is what we call the bridge generators. So let me type it in so I can talk while it's working. Create a new Rust CLI application outside of this Golem app that uses the generated bridge client to call repository query and exposes all its features via a CLI tool, something like this. So the bridge generator is something you can call by hand with a CLI command, and also you can configure it in your app manifest that you want always you want it to be part of Golem build. And it's now going to, yeah, it does that. It asks that we want a bridge for the Rust language for the repository query agent and to put it there. So what it does every time you build your agent using Golem build, it's also going to build a full self-contained Rust crate that has a typed API to call your repository query agent from outside of Golem. It's a regular Rust crate. It can be used in any Rust application. And we support bridges currently for Rust and TypeScript. So you could use TS here, and then it would generate an NPM package that you can use in any TypeScript application as well to call any Golem instance in a very nice typed way. It uses the same interface that you use for RPC and in the REPL. So everything is aligned. And it's already trying it out. It's called Golem build. And here you can see generating Rust bridge. And it's checking that it's there. It has a cargo file and the source directory. And it's also going to create, yeah, it's learning how it looks like. And now it's learning more about how it looks like. I don't know why. But in the end, it started creating this CLI source, CLI directory here. And it's not there yet, but we can open this one in IDE as well. Trusting it. What can go wrong? Yeah, it's figuring out how to configure it. Because before you invoke your in this case the repository query agents with this library, you have to configure what Golem instance you want to target. And now we are going to target the local one, which actually has a very simple built-in switch, but it had to figure that out. And as you can see, it created a CLI Rust code that uses clap for the CLI interface, a repository query client that is the local dependency on the generated crate. And it already written the code. And now building that with cargo. And we can take a look. So cargo file depends on the repository query client, as I said. And the main thing is just defining the CLI interface. And it has subcommands for everything that we were exposing. And yeah, it already, I think it generated all kinds of CLI options to be able to connect to any Golem instance, local, cloud, custom running, everything. And yeah, it's using this configure call to set that up. And after that, it's basically the Rust equivalent of what I was showing in the REPL, for example. Here, we could use get if this wouldn't be an ephemeral agent, but it is an ephemeral agent. So we use new phantom, which creates a new instance all the time. And then we can just call agent.list, for example. So here we have the typed interface of our file repository query agent. I mean, client calls for all this, but it's all typed. It always supports the trigger and schedule and everything. And yeah, it's already trying it out. It's now checking the help page, which works. And it's deleting the existing agents and expects the CLI to recreate them, I guess. Yeah, it's calling CLI list, register, list, hash, all these things, and then asking, what is this repo? Tester is a test framework. So everything works through the CLI as well. And if we take a look at the agent list, it's once again, it's there. because the CLI calls were accessing them and recreating them. And that's everything I wanted to show, I think. Let me stop sharing my screen and get it back to John.
Fantastic demo. That's a lot to show in just a little over an hour. All right, let me share my screen and we will continue. We're almost done. All right, so as you can see, Golem 5 is very, very powerful, and you can use all of these features together to build very quickly, I think, quite powerful custom AI agents. So what's next? Well, what's next is the Golem Forge Hackathon, which is kicking off right now. So the prize for this hackathon winner is $2,500 in cash. We pick the winner. What's the problem? Well, you got to build an agent, or rather an agentic application on Golem, and not just any agentic application. What we're aiming for this hackathon is you should build some sort of super scaled down version of OpenClaw. The basic idea behind OpenClaw is that you should be able to have basically an army of artificial intelligent information workers at your disposal who can do stuff in the real world for you by interacting with different services, and that you communicate to on Slack or Discord or Telegram or WhatsApp, or maybe even text them. And it's been phenomenally successful, very successful open source project. And what your goal as part of this hackathon is to build a super scaled down version of that, which allows a human to interact with agents and spin up new agents purely through a high level text-based interface. And we're picking Telegram for this. So Telegram has that's the only one you have to support. If you want to go crazy, you could support more, but Telegram has like a very free way to use it, very easy to get up and running. You don't need to do fancy verification. You don't need to pay money. So it's a great channel for interacting with this toy agentic application. And the idea is you type in some message to Telegram to some agent that's being running in Golem, and you're able to give it instructions to do basic things. You're going to be using an LLM to build this. And the one I recommend is Gemini Flash, because there is a free tier that you can use probably for development and testing. And then the agents, they're going to be basically per user. So you're going to have a multi-user, multi-tenancy sort of design where multiple different users can interact with your system, and they won't all see each other's information. And every single agent that's running on behalf of a user is going to have its own local memory, of course, to do some specific task. But it's a requirement for all the agents that are running on behalf of a user should have access to some sort of shared memory. And the reason, or rather the application there, is you might have one agent who's booking a dentist appointment for you, but another agent who is trying to book you flights. You don't want the dentist appointment to overlap with some other event, and other types of things like that. They require shared memory. So you're supposed to build some sort of shared memory system. You don't have to actually build anything. Golem has everything you need to do shared memory and local memory as well, but your agent should use them effectively in some fashion. It doesn't have to be super fancy, but there should be some sense of this agent learns this thing about you. This other agent over here knows that and can access that information. Your Golem Claw should support at least the following 4 tools: reminders. In other words, I type in to Telegram to my my Golem Claw, and I say, I want you to remind me of this upcoming dinner date that I have. And then, an hour prior or whatever it is, you get a reminder. You get a Telegram message saying, hey, you have a dinner date in an hour. So reminders, basic reminder feature that also would allow you to cancel reminders or list all the upcoming reminders that you have. Weather, so you can type into that Golem Claw agent, say, what's the weather around here or in that specific location, and it's going to check that for you. Do web search, so you can say, hey, Golem Claw, I want to go out there and find the best tie that's between $20 and $30 and whatever, and you would get back some sort of an answer for that that's powered by a web search tool, and then some sort of email facility. And this one may be the hardest one to get working. So it doesn't have to be too fancy. You could just use the default email here, or you could try to go down the path of actually allowing the end user to authenticate using Gmail or something like that. But at the end of the day, it should be possible for the Golem call agent to send an email on behalf of the user, not necessarily using their own email account, although you're welcome to do that if you want. And then if you want, if you have done all of that in the span of an hour and you have 71 hours left, then you may as well add some more tools just to help increase the odds that you're going to actually win the hackathon. A stack, you can use basically whatever you want as long as it runs on Golem. So you can pick your own programming language up to the limit of the ones that we support. You can pick Scala, you can pick Rust, you can pick Moonbit, and of course you can pick TypeScript. Of all of those solutions, I would say that probably Rust is going to be the fastest, maybe Moonbit is the fastest, and then the TypeScript one is going to be the most feature rich, just in the sense that you can grab any libraries off the shelf and use them. They're probably going to work just fine on top of Golem. There is a restriction, however. In building this, we don't want you to spend a bunch of money, right? And also in testing it, we don't want to have to spend money. So if you decide to use web services like Twilio or whatever, make sure you stay on the free tier. Right? Use developer trial accounts or something like that. Don't actually incorporate paid accounts into your service. That's going to cost you money. It will also cost us money when we go to test that. So please don't do that. To submit your solution to the Golem Forge Hackathon, bundle it all up in a zip and send it to contact@zyverge.com. Don't submit a repository because it's very easy to update that and we don't know exactly when you sent it. Email, on the other hand, has a very firmly established date of reception when the server sees that email package, and it can't be changed after the fact. So that will help us ensure that everyone submits before the deadline and doesn't have a chance to update things later, to make it fair for everyone. Another requirement is that you have to deploy your agentic application, your Golem Claw application, to Golem Cloud. So Golem Cloud is our own hosted version of the open source edition, and it's currently purely in developer preview. We don't have a way for you to pay us money, so don't worry about that. It's all free. We're just trying to make sure that everything is working properly with this 1.5 release. And who better to act as our beta testers than hackathon participants? So give it a try. Let us know if you run into any problems. You should end up deploying your app to the Golem Cloud. Our deadline is, again, on Monday, May 18th at 12 noon EDT. So what's going to happen is all those submissions will be reviewed. If they were delivered in our inbox after 12 noon EDT, then they won't count. And we'll announce a winner by the end of next week. So it should be a relatively fast decision process. If you have any questions, then of course ask us on Discord. That's the most important part of the Golem Forge Hackathon, is joining the Discord. There you can ask questions, get clarification. You can also talk to other Golem users who've maybe been through some of the challenges that you're going to face over the course of the next 72 hours, and you'll hopefully get answers to your questions. All right, so now what I'm going to do, I think that's all the material I have. I'm just going to run through Discord and make sure there's no questions. We had one question, just problem, I guess, installing Golem on a Mac. I suggest you just ask your coding agent to install it from source code. That will work. It will get around whatever sort of operating system specific security limitations prevent unsigned binaries from running on your system. And also you can make sure you use either the 1.5.1 release, or if necessary, you could even use a later one, although it's not recommended.
Yeah, and it's going to take a lot of time to compile it. So I would still recommend downloading the binaries, but
it's
if you
not
have
that
problems
bad. It's
with
only
it,
45 minutes. All right, anything else we should
depends
tell
on the
folks,
machine. Not really. There is a quick start page on the learn.golem.cloud website. That
let me show
is
that real quick.
that is supposed to be up to date and telling the latest way to download and get started.
Oh, this is a really great resource. This is all up to date. And you can see how you develop for Golem in different languages, how you do deployment stuff, invocation, debugging, operating, how you use the command line interface. Obviously, your agent's going to figure out a lot of this for itself if you're using one to build it, and I certainly hope you are. But also, you might want to understand key concepts like API gateway or agents, agent-to-agent communication. There's also a bunch of how-to guides. We took our skill files, which are actually made for agents, and we turned them into how-to guides for humans. But also, you can point your agent at this documentation resource, and it's going to have just a ton of stuff here. And then also, if you do actually build Golem from source, I recommend pointing your agent to the Golem source code. That way, it can always answer questions that you may have and not know or that your coding agent might have, and that whose answers might not be contained inside the documentation. Although we've tried to make that as up to date and complete as we reasonably can. Anything else, Daniel?
I don't have anything else.
All right. Well, thanks for that excellent presentation, live coding of Golem 1.5 features. And thank you all attendees for watching this release. I invite you to participate in the hackathon. It's only 3 days. You can have your coding agent do the work. You're going to have a blast, and we're going to appreciate hearing your feedback and seeing what sorts of fun things you end up building on Golem. And we'll see you all next week. Take care, everyone. Bye-bye.